All right, this is for Algebra 2. We are just starting parabolas from lesson 24. And there'll be another one, probably two more videos. This one is from your book. Now, first of all, whenever you see, how do I know this is a parabola, is I only have one variable squared. Notice just the x's squared and not the y. So without even graphing this, I want you to get to the point that if you see the x's squared, if it looks something like this, the x's squared, I know it's going to be a parabola that opens up. And that's supposed to be a vertex of 0, 0, but I'm looking through my phone. Okay, so it's going to be just something like this. Ooh, that's beautiful. Let's hope the next one's better. Okay, and we talked about this in class. If you would have a negative out front, notice the x is still squared. So typically the parabola would open up. But now, okay, your parabola is going to look like this. It's going to open down. It flips it upside down. Okay, so let's get a visual that if the x is squared, it's either going to open up or down. So look at this. Do you see how the x is squared and this is positive? So I know it's going to go up. It's going to be a parabola that goes up. Now, notice nothing is being added or subtracted here. It's pretty boring. So I could tell you my vertex is 0, 0. Unlike, and I'll get to this here in a minute, we did some like this on your worksheet where we knew our vertex. See how there's things added and it's just not as pretty? My vertex here is going to be negative 10, because that's what makes it 0, 1. My vertex here is 7, and then what's added on the end is a 1. So my vertex here would be 7, 1. Okay, but we're going to do those more interesting ones here in a little bit, but here my vertex would be 0, 0. Another way you can tell that and is the lovely t-chart. See, it looks, says plot several points to confirm. Since this is solved for y, that means the y is all by itself. I'm going to plug in values for x. So if I plug in a 0, plug in a 0 and see what you get. 0 squared is 0. 0 times 3 is 0. So there's your vertex, 0, 0. I'm going to peek under my phone here. Okay, plug in something else. If I plug in a 1, notice, plug it in. 1 squared is 1 times 3 is 3. You should get the same thing even if you plug in a negative, because it's going to be symmetrical across this y-axis right here. If you plug in a negative 1 and squared, it's a positive 1 times 3. So you get negative 1, 3. So I'm going to go ahead and plot those points. 1, 2, 3. And we can plot in one more. It might shoot off the graph, but let's look. If you plug in a 2 and you square it, you get 4. 4 times 3 is 12. And it's going to also have this value in there because, again, it's symmetrical. So 212 probably comes off, but it's going to be somewhere up here. I'm going to estimate them. And then what I need you to do is make sure you do a nice smooth curve through here. Put some little arrows on the end. Okay, so it's going to look something like this. This is not a sharp V. Now, this is a nice smooth curve. So what happens when you have a number out front, okay, this makes your parabola go up 3 times as fast because it's pretty skinny. If you had just y equals x squared, it would be more out here, okay? So if there's a number out here, it's going to go up 3 times as fast. Now look at this one. I already kind of graphed this one for you. The x is squared. It has a negative out front. So basically it's going to be a parabola that flips upside down. Okay, it's just going to look like this. It's going to be your normal parabola. If you need to, make a little t-chart. Plug in 0. 0 squared is 0. There's no such thing as a negative 0. So there you go. If you plug in a 1, notice if you square 1, 1 squared is 1, but there's still a negative sitting out there. Okay? The negative here is not squared. So like when you plug in a negative 1 and you square it, negative 1 times a negative 1 is a positive 1, but you still have the negative out front. Okay? And then if you plug in a 2, 2 squared is 4, so it's going to be a negative 4. So this doesn't change at all. So if you plot these points, and I'm going to peek, and I got shadows, I'm going to have to move. There's your 0, 0, 1, negative 1, negative 1. Here's 2, 1, 2, 3, 4, and negative 2, negative 4. So it's going to look something like that. Just make sure you give me a nice smooth curve like that. It should look just like that. Okay, this is not a V. Okay, I want a nice gentle curve with arrows on the end. So it looks just like that. This is the standard parabola, except this one happens to be upside down. See how this one's a lot skinnier? Again, it's because there was that number out front. Okay, now let's do this one. Notice there is a number outside, but it's a fraction. So instead of it going up 3 times as fast like this one, it's going to go up 1/3 of the rate. So it should be really fat. Now, the x is still squared, so what it tells me is it's going to open up and he's going to be fat, like this, because it's taking him 3 times as long, or he's going up a third of the rate, okay? But again, you know, plot a couple points and see what you get. If you plug in 0, you're going to get 0 times 1/3, which is 0, okay? So there's my vertex right there. If I plug in a 1, I'm going to get 1/3 times 1. Same thing if I plug in a -1. So that's kind of boring. Let's plug in a 3. You could plug in a 2, but what I was doing is I was looking ahead, because if I plug in a 3, I get 3 squared, which is 9, and I can take a third of 9. Okay, that's like dividing it by 3. So I'm trying to get something that was not a fraction. Same thing if I plug in a -3, because when you plug in a -3 and you square it, you get a positive 9, and a third of 9 is 3. Okay, so we're going to plug that in real quick. Now, when I go over 1, I can only go up a third, so you can see it's not going to be very far. I'm just going to have to estimate that fraction. So that's why I like these better a little bit, but you're going to have fractions and you're just going to have to kind of estimate. 1, 2, 3, 1, 2, 3, there it is. 1, 2, 3, 1, 2, 3, there it is. Okay. If you need another one, I'm trying to think, gosh, even if you would plug in like a 4, you would get, let's see what you'd get. If you plug in a 4, you'd get 16, so you would get 16/3, which we know that that is 5 1/3. So if you plug in 4, 1, 2, 3, 4, 5 1/3, you know it's going to be right there. And then we're going to have the mirror image over here. 1, 2, oops, I can't see. 1, 2, 3, 4, 1, 2, 3, 4, 5 1/3. So right there. That's what I get for looking through my phone. So you can see, nice smooth curve. Try to hit your points. Put little arrows on the end, okay? So it should look just like that. Notice he should be a lot fatter than this guy, okay? So I let you skip in your book, you know, on lesson B, the ones for C, where it is that it asks for, you know, what's the coefficient out front. I did a video on those if you want to see it, but don't worry about it. Okay, notice here now the y is squared. So you think about this. When the x was squared, it opened up. It makes sense here. If the y is squared, it's going to do the opposite, and it's going to open to the side. So this is positive. The y is squared, so it's going to be a parabola that opens this way. It's got a 4 out front, so that means it's going to do it 4 times as fast. So I'm just thinking maybe it's going to be this really skinny parabola that opens up to the side. Okay, now here's the trick. Since you've solved for x is all by itself, you want to plug in values for the y. So if I plug in y right here, you're going to get 0 times 4, which is 0. So there's your vertex right there. Okay, if you plug in a 1, notice plug it in for the y, you're going to get 1 times 4, which is 4. Plug in a -1. When you square it, use a positive 1 times 4. So we could go ahead and graph that. 1, 2, 3, 4, 1, and a 4, -1. There it is right there. That's probably enough. I mean, if you want to plug in more, that's fine, but you can see it's going to get really big. If I plug in a 2, 2 squared is 4, 4 times 4 is, what, 16? So gosh, you're way out here, and it's going slow. It is getting bigger, but, oops, I missed it, but really slowly. So there's you a very skinny parabola, like we talked about, that opens to the right. Okay, I like this one because for the first time we have something added right here, okay? But again, the y is squared, so typically I would think it's going to open here to the right, but because it has a negative out front, it's going to flip it over, so it's going to open to the left, okay? Now let's see what happens to this one. Let's do our little t-chart. Again, since the x is all by itself, plug in values for the y. So if you plug in 0, this becomes 0 plus 1. So there is going to be my vertex, 1, 0. Okay. How about if we plug in 1 over here? If we plug in 1, we're going to get a -3 plus 1, which is -2. Watch what happens if you plug in a -1. If you plug in a -1, you still get 1, right? Because you square it, you lose your negative. 1 times -3 is -3, plus 1 is -2. So let's do one more. Let's plug in a 2. If you plug in 2 squared, you get 4. 4 times -3 is -12. -12 plus 1 is what, -11. So, woo! So let's do this. We've got -2, 1, And we've got -2, -1. And then if you went way out here, estimate 11, it would be up finally to 2. So again, we knew it was going to be skinny because we had a number out front here. So it's going to look something like this. Nice, skinny, smooth parabola. I'm looking through my phone. We had a little shakiness going on right here. Okay, but again, this is not a sharp V, just a nice, sharp, smooth curve like that. All right, so hopefully that will help. I'm trying to look ahead at your homework. The only one I see that might cause you grief is this X has to be by itself. So if it's not, this is from 24B number 2, the very first thing I would do is be dividing everything by 2 because you want to get something by itself, the one that's not squared. So here I want to get the X by itself, so I'm going to start with this. Okay, so if the X isn't by itself, fix it. This is a Y that's squared and it's negative, so I already know it's going to open to the left. And a little trick here, do you see how when you added one, it shifted to the right one? Well, I can already guess that this is going to shift to the right 4. So, I mean, you're going to get to where you're really good at these, so you know it's going to be something like this, okay? But just plug in some points on these and keep it simple, all right? Trying to see if there's anything else. I can see here on 24B, they're trying to be mean to you on this one. Whatever's to the first power is what needs to be by itself. So I would write this one, move this 1 to the other side. So I would write it like that. Make sure the one that's to the first power is by itself. And there you go.